Okay, and lastly, let's cover the Ancova. This is the analysis of covariance, and it has a covariate in it, a continuous variable that is affecting the dependent variable that you want to kind of parcel out. Notice that a covariate is not the same thing as a confounding factor. A confounding factor affects both the IV and the DV, whereas a covariate only affects the DV. So why would we include covariates? There might be two reasons. One is to reduce the within group error variance that will help us increase the F statistic to make things more statistically significant. And we also just want to eliminate other explanations for what could affect the DV. So maybe we don't care about the effect of the covariate. We want to parcel that out. So those are two reasons why we might include that in our Ancova analysis. When doing the Ancova, there's two additional assumptions. One is that there's independence of the covariate and the treatment effect, that the covariate does not relate to the independent variable. And so we test this by running a one-way ANOVA, looking at the experimental manipulation as your IV and your group variable, or and your covariate as your DV. And if it's significant, then you violate this assumption. So we'll test that in a second. And then the last one is that there's homogeneity of regression slopes, such that the relationship between the covariate and the outcomes must be similar across groups, so that there's not, it's just similar. So it's both independent and homogeneous. So we can test that as well. And we add an interaction term and just test that. So let's walk through it. We're going to perform the test. I've already opened up the data set. It's the Ancova data set from the LSJ data. This is fictional data from a health psychologist who was interested in the effect of routine cycling and stress on happiness levels. So we actually have an Ancova, but it's a 2x2 independent factorial design with a covariate. So we're going to go to ANOVA, Ancova. Our dependent variable is happiness. Our fixed factors are stress and commute, and our covariate is age. And so technically we should actually go back here and change this to make it continuous. That is better. And go back here. So now that's fixed. Okay, we've moved all those things over. We want to select omega squared. We're going to check all the assumptions. What else do we need to check? You can tell I don't do Ancova very often either, huh? Yeah, post hoc, we'll just do all of them with 2 keys. I'll ask for Cohen's D as well. We'll do both of these. And we can ignore that. Okay, so we've got all of that. First, though, we need to check our assumptions. So we can check the basic assumptions here. Homogeneity of variance, not significant, good. Normality, not significant, good. QQ plot looks good. We should also check for our skew and kurtosis on happiness. We're going to skip that for now. But we also have those 2 additional assumptions, right? We have the assumption that they are independent and that they are homogeneous. So let's do the independent first. And like I said, for this one, we would run a one-way ANOVA. So I'm going to just add another one, looking at how these both affect age, our covariate, right? And so we have ANOVA age, stress, commute, and so on. And we see that there is a significant effect of stress on age, and almost as significant, but it's not interaction effect. So we actually violate this assumption between stress and age. Let's see, where do I write? This suggests that age is in fact a confounding variable, not just a covariate. So that would mean we'd actually be wanting to perform a mediation analysis, but we're just going to continue so we can talk about Ancova still. So because stress and age are related, age is a covariate with stress, and so that's problematic, but we're going to continue anyways. The second is that the relationship is similar for all levels of the independent variables, so we need to add these interaction terms with age. So let's go back here. We're going to add an interaction effect. We're going to do this all two ways. So I've just added the age interactions, and these stress and age, commute and age should be non-significant. They are not significant. Therefore, we meet the assumption of homogeneity of the covariate, right? There is no interaction effect between the two. So we meet the second assumption, don't quite meet the first assumption, but we're going to continue anyways, okay? And we're going to take those back out because we actually don't want to be testing that. We don't care about that. We just want to control for the effect of age. Okay, we've met all of our assumptions. Now we can go through and interpret. So we interpret it pretty similarly. Is there effective stress? Yes. Is there effective commute? Yes. Is there effective age? Yes. And is there significant interaction between stress and commute? Yes. Okay. We've already checked our assumptions, so we can then go here. I don't quite remember what the two groups are, but people in the 2 stress condition. Let's see, do I have it here? Yep, in the low stress condition. People in the low stress condition have lower levels of stress than people in the high stress condition. Go figure, right? Huge effect on that. And then people in the commute, let's look at what that means. 2 is cycling. People in the cycling condition have lower stress than people in the driving condition in their commute. Again, pretty big effect. And we can look at this. And so we have our not the effect on stress, the effect on happiness. Whew. So we have low stress has higher happiness than high stress. And people in the cycling commute have higher happiness than people in the driving commute. But we also see an interaction where there doesn't seem to be much difference here, and we can check that in a second. But there's a significant interaction such that people in the cycling commute have higher happiness than people in the driving commute in the low stress condition. Whew, that's a lot. And we can check that here. Oh, I should really, this is getting annoying. We're going to change this, right? So stress, this is high and low. And this is drive and bike. And now it's going to change everything. And now I can interpret this a lot easier, right? And now drive and bike, awesome. Awesome. So we see that there's a significant effect of high drive and low drive. High stress and drive on low stress and drive. So there's a significant increase here, or not increase because not within subjects, right? Significant difference here. I would guess high drive and low bike. Yep. High drive and low bike. Yeah, that's a big effect. Big difference. High drive. No, that's it. And then high bike and low bike. Yeah, high bike and low bike. Good. And then low drive and low bike. Low drive and low bike. Oh, low drive and low bike. Yep. Yeah. So significant difference here, significant difference here, significant difference here. But then there's no difference between high bike and low drive. We can check that. Low drive, high bike, and low, where would that be? High bike and low drive. Yep, no difference there. And there's no difference between high drive and high bike. High drive and high bike. Nope, no difference there. Cool. So everything else is significant though. Oh, lots to examine, right? And all of this is when we control for the effects of age, right? That's an important caveat. We're controlling for the effects of age. So let's walk through the write-up now. Whew. Okay. We conducted a study examining how stress and commute affect happiness levels in a 2x2 independent factorial design. Furthermore, we collected data on age as a covariate of our study. We satisfied all assumptions of Ancova, except that age was in fact a confounding variable in that it relates to our independent variable of stress. Despite failing to meet this assumption, we proceeded with the Ancova analysis. Note, I've tested it, I'm transparent about it, but I explain why we're continuing on, or that we are continuing on, right? Probably should explain why, because this is a teaching example, right? But I'm being very transparent in everything. Okay, let's go do this side by side. Get this back up. There we go. And side by side. Okay. There was a significant main effect of stress on happiness, right? Such that participants in the low stress condition reported significantly greater happiness than participants in the high stress condition. So I pulled the means and standard deviations and the F, 1, 15, 52.61, etc. There was also a significant main effect of commute on happiness, such that participants who commuted via cycling, we can check all this here, right? Cycling had higher happiness, reported significantly greater happiness than participants who commuted via driving. Can I note real quick that the parallelism here, I've basically copy-pasted the sentence and just did it the same way. Writing things up like this is not like our level of creativity is writing things up in a way that is clear, succinct, and understandable for our audience. But parallelism here, reporting it the same way, can really help the reader understand what you're doing. As soon as you start changing things up, it's going to start confusing people. So note that parallelism. It's a good writing tool. Okay, so there was a significant main effect of commute on happiness, such that participants who commuted via cycling reported significantly greater happiness than participants who commuted via driving. Same thing, F 1, 15 equals 42.33, etc. There was also a significant interaction between stress and commute type, such that happiness levels were similar in the low and this is wrong. Happiness levels were similar in the high stress conditions for both commute types, but happiness was significantly higher for participants who cycled versus those who drove in the, and I believe this is supposed to be low stress. Let's just double check this because I think 2 is supposed to be low. Yeah, so that's backwards in the write-up. So happiness was significantly higher for participants who cycled versus those who drove in the low stress conditions. That was slightly wrong. So where am I getting all of this? This is the interaction effect, right? And I could put in those simple effect stuff from here. That's fine. And then I just added, furthermore, age was a significant covariate of our dependent variable, and I just write up that result as well. And I could interpret it. Let's see, how would I interpret that? Because I don't think I can add age here. Oh, no, here, yeah. So, we're just controlling for the effects. We're not really caring about like what that effect is. We're just controlling for it and trying to kind of parcel it out as opposed to examine it. So that's the Ancova. Let me know what questions you have.